In this video lesson, we'll be looking at solving systems of equations. By systems of equations, we simply mean when we have two equations, we are going to solve them by finding the x and y ordered pair that solves both these equations. So let's just take a look. What we need to understand is that when we're looking at systems of equations, we're either going to find one solution, or there may actually not be a solution, so no solution, or we may actually find an infinite or infinitely many solutions. Let's take a look. You can see on this slide here that we have two equations. Now they're both in y equals mx plus b form, but this would be a system of equations. They're both graphed here, and you can see that they intersect. And where these two graphs intersect is the solution to this system of equations. This is 1, -1. But what I also need to point out is that we can look at this system and we can see that they have different slopes. This has a slope of -3 and this has a slope of +2. Well, the fact that they have different slopes means they are going to intersect and they're going to have one solution. So again, if our system of equations is going to have one solution, it's because they have different slopes. All right. On this slide, we have a system of equations that actually has no solution. The reason they have no solution is because these lines are parallel and they will never intersect. But remember, if lines are parallel, it's because they have the exact same slope. Now this first one is in slope-intercept form, or the blue graph, but the red graph is in standard form. But you can see here, if we take the standard form and convert it to y equals mx plus b, or slope-intercept, you can see that they both have a slope of 5/1. So these will be parallel and will never intersect, and that makes them no solution. On this slide, we have another system of equations, and the solution to this system is infinite solutions, or we might read infinitely many solutions. Again, we have one graph in blue and another graph in the dashed red line. You can see they're right on top of each other, so they are the exact same equation. One is in slope-intercept form, y equals x plus 2. This one is in standard form, but if you were to convert this standard form to slope-intercept form, it would also say y equals x plus 2. So obviously the same graph, all of these points are solutions. So you could plug in any x and y ordered pair into these two solutions and they would both be true equations. Okay, so let's take a look at an example that you will see. This says to determine if the following system of equations has no solutions, infinite many solutions, or exactly one solution. Now, there's many different ways to solve this problem, and you could simply graph them, maybe using Desmos and C. But what you also want to notice, again, if the answer is no solution, it's because they have the parallel slope. If it's infinitely many solutions, then they're the exact same equation. And if it is one solution, it's because they have different slopes and they're going to intersect. So what we would need to consider is to put these two equations in slope-intercept form. So let's go ahead and do that on the next slide. So this will be a little bit of review of solving for y, or putting these equations in slope-intercept form. On this first one here, we are going to subtract 3x from both sides. So our equation becomes 2y equals -3x minus 1. And then we divide by 2, divide everything by 2. So our equation becomes y equals -3/2 x minus 1/2. All right. And then for the Other one over here on the right, we're trying to solve for y, so we're going to subtract 6x from both sides, and our equation is going to become 6y equals negative 6x minus 5. And then when we divide by 6, again, we divide everything by 6. So our equation becomes y equals negative x minus 5/6. Well, you can see that they have different slopes. We have a negative 3/2 or negative 1 1/2 slope, and this is a negative 1 slope. So obviously these are going to intersect, and you're going to have one solution. Now remember, there are different ways to solve these problems. So when you're working on the delta math, you may see different examples of how to solve it. But I want you to solve your equations for y. This is how we're going to solve in this class. Put it in y equals mx plus b form, and then identify the slope. And again, if the slope are different, you're going to have one solution. If the slopes are exactly the same, you'll have no solution. And then if the slopes are identical, or if the equations are identical, then you'll actually have an infinitely many solutions.